Hello everyone, my name is Raymond Burchard, and this is my prototype presentation for my climate control for a plant cabinet project. In this presentation, I'll be going over the project description and objectives, and I will discuss the first prototype of my circuits and go over my updated timeline. This project is to make a system of circuits to help me control the climate inside a plant cabinet. The objective of this project is to have a system in place that will not just show the conditions of the inside of the cabinet, but will show indications that the conditions are within certain parameters. This will increase the profitability of the plant business by increasing the growth and health of the plants. In the next few slides, I will go over information of the first prototype I've done for this project. These are the main components of the system. The humidity system uses an LM339 op amp and 3 LEDs to indicate that the humidity is within 3 different ranges: 10 to 45%, 45 to 75%, and above 75%. It will achieve this by using the output of an HIH4030 humidity sensor to give a signal to the op amp circuits. Depending on the signal, the different op amp circuits will turn on and power an LED. The soil moisture sensor works by using the varying resistance of moist soil to change the charge-discharge speed of capacitors in the system. This makes the LEDs flash at different rates depending on the resistance. I decided to use a pre-built circuit for the temperature sensor. The W1209 in the picture has the exact features that I needed for this project, and it wasn't very expensive. At this point, my design does meet all of the specifications of my initial goal, and I'm really pleased with the outcomes of the circuits. As I do more testing, I'll decide if I want to keep the logic portion of the project and make adjustments to humidity system if I need a smaller range increments. Here are pictures of the prototype circuits that I've put together. The humidity system is incomplete. I'm waiting on a few resistors and the HIH4030 humidity sensor. The soil moisture system works as intended. I just need to finalize the layout of the miniature breadboard and trim the leads on the components to save some space. The temperature sensor is complete. I decided to put a red LED on the output that'll turn on whenever the output turns on. I've tested the function of the temperature system. It's easy to set up the output, and I tested the reading from the probe using a Fluke 971 temperature and humidity meter. I'll show the testing results for the soil moisture system in the next slide. I've not tested the humidity system because I'm still waiting for components, and I'm not going to build the logic system until I've tested the humidity system to make sure I still want it as part of the project. Here you can see two examples of the soil moisture system working with two different plants. The plant on the left is much drier than the plant on the right, and as you can see, the light switch much slower on the drier plant. The plant on the right has been watered in the last few days, and the soil moisture is about perfect. The plant on the left is going to need to be watered within the next week. If the probes were left in either of the plants, the lights would slowly start to switch slower as the soil dries. This function works really well for this system. Here's my timetable. I'm starting to get caught up with the project, and when I get the last few parts for the humidity system, I'll finish that prototype and I'll be back on track. And here are all the references that I've used for this project, and that's all. Thanks.